This is the lesson for geometry part 5, which is about volume and surface area. Now, as you can see from the first page of these notes, there are a lot of formulas to remember for volume and surface area. So volume of a space figure, so a space figure is three-dimensional. Volume is what you use to measure its capacity, or if you were trying to fill it with water, how much water would you need? So volume is filling up a three-dimensional figure. Surface area is the total area that the surface would cover if you like if you peeled it apart, or if you tried to cover it with wrapping paper, like, not necessarily with all the folds and everything, but just kind of smooth the wrapping paper over. How much area of wrapping paper would you need to cover that space figure? And there's going to be two kinds of space figures that we deal with in this class. So we're going to deal with pyramids and or cones. I would classify those as one kind of figure. Oops, not the cylinder, sorry. Now, check out these three pictures. What's similar about them? Well, they all start at a shape, which I will refer to like as the bottom, and then they all end at a point. So there's a shape on the bottom and a point on top. So those kind of figures are going to have one kind of formula, versus these other figures, like these guys here. Those guys start at a shape on the bottom and the end at the same shape on top. So we're not going to be dealing with a lot of like weird shapes where, maybe it starts as a pentagon on top and then it morphs into a square on bottom or something. We're just going to be same shape to same shape. So the trick for volume, there's going to be two formulas. And I know you see all these formulas here for volume, all the ones for V are volume. But let me show you an easy way to remember the formulas for volume, okay? So if you've got a space figure, which is shape to shape, and I should say the same shape. So shape to shape, you're going to take, so the volume is going to be equal to the area of the base times the height. Now, the area of the base is different depending on the shape. So if you know your area formulas for the different shapes, then when you're calculating volume for shape to shape, you look at the area of the base and you just times it by the height. Now, what if you are having a cone or a pyramid? So when your figure is shape to point, I think everyone would agree that the volume is smaller than if it was shape to shape. So what we're going to do is we're still going to take the area of the base and times it by the height, but then we're going to divide it by 3. Why 3? Because that's the rule. That's the rule for all figures, all space figures that start at one shape and end at a point. Their volume is going to be this almost the same as a shape to shape figure. We're going to do area of the base times the height. But then if it ends at a point, you just divide that value by 3. And again, the area of the base is different depending on the shape of the bottom or the shape of the base. For surface area, I don't really have too many tricks for surface area. Most of the time you just have to memorize those surface area formulas. So when we do these problems, you'll see me go back and forth between this page, which gives the formulas, and the problems that we're doing. Okay, so here's that volume hint here. Let's find volume and surface area of these figures. So here's figure 1. This is a box, right? And the base of the box is a rectangle. So if I want to find the volume of the box, it's going to be the area of the rectangle times the height. So let's look at area of a rectangle. So this rectangle here is 6 inches by 5 inches. So the area of the rectangle will just be length times width, or baby base times height, baby height. So we'll do 6 times 5. So the area of the rectangle is 30 square inches. Now let's do the height. So the height is the third dimension here, right? So how tall this box is, well, in this case, the box is 3 inches. So the height is 3 inches. So we'll be doing 30 square inches times 3 inches. So 30 square inches times 3 inches. And when you do that, you get 90. And then inches squared inches to the first makes inches cubed. So these are cubic inches. Now, for surface area, right, because this problem wants us to find both volume and surface area. So for surface area, what you're going to do is you're going to refer back to the formulas. So let's get a different color pen here. And let's look back for the surface area of a box. So here's a box. The surface area of a box is 2 length width plus 2 length height plus 2 height width. So let me write that down. I kind of ran out of space. I was writing too big, sorry. So the surface area is 2 length width plus 2 length height plus 2 height width. And so here, you can pick any one of these to be your length, any one to be your width, and any one to be your height, as long as they all have their own numbers. So I will do length as 6, width as 5, and height as 3. So that becomes 2 times 30 plus 2 times 18 plus 2 times 15. So that makes 60 plus 36 plus 30, which makes 126. Now, what are the units on that? Well, remember, length was inches, and width was inches, and height was inches. So each one of these multiplications made square inches. So this will make square inches. So the surface area is 126 square inches, and the volume is 90 cubic inches. Okay, let's try again. So in this picture, we've got a right cylinder. So the base is a circle, and volume will be area of the base or area of the circle times the height. So you have to go back and think about what was the area of a circle. That was pi r squared. And here they tell you r is 5 centimeters. And they tell you to use 3.14 for pi. So if I was just calculating the area of that circle, it would be 25 times 3.14. So this would make 78.5 square centimeters. But now we have to level up and we got to put the height on there. So the height is 7 centimeters. I guess I'll go all the way here. 7 centimeters. Remember, this was centimeters squared, and this is just regular centimeters. And when I times these two together, the units become cubic. So cubic centimeters. And in my calculator, I'm going to take 78.5 and times it by 7, and that gives me 549.5 cubic centimeters. For surface area, we're going to go back and we're going to look at that formula. So the surface area of a right cylinder is 2 pi r h plus 2 pi r squared. So 2 pi r h plus 2 pi r squared. And let's start filling these in. So remember, we're replacing pi with 3.14. We're replacing r with 5. And we're replacing height with 7. So 3.14 and then 5 squared. And we're going to times all those by 2. All right, so let's get some numbers in our calculator here. So I have 2 times 3.14 times 5 times 7. That makes 219.8. And then plus 2 times 3.14 times 25. 2 times 3.14 times 25 makes 157. And now I'll add those two numbers together, and that gives me 376.8. Now let's go back. We have to figure out the units for this. Because this is a surface area, it's an area, so the units are cubic or square units. So I would have square centimeters, and that would be the surface area of that can or that right circular cylinder. Now let's try it again. So here is a sphere, and we want to find the volume and the surface area of the sphere. Now a sphere doesn't fall into the tricks, so you do have to just memorize the volume of a sphere. So let's go back and look at it real quick. Oops, there we go. The volume of a sphere is 4/3 pi r cubed. 4/3 pi r cubed. Okay, well, we don't actually have r. We've got d, right? We've got the diameter all the way across. We want r, which is only halfway across. So we've got like a little pre-step here. Find the radius, we have to take that diameter and divide it by 2, which gives you 7.4. So that's my r. Now in this one, it does not say to change pi to 3.14, and it doesn't say to round your answer. How could that be? What we do here, if there's no rule in the directions of how to handle pi, then we leave it just looking like a pi. So what we're going to do for volume is we're going to do 4/3 times pi times r cubed. So let's do r cubed first. 7.4 times 7.4 times 7.4 makes 405.244. Let me just do that one more time just to double check that number. So 7.4 times 7.4 times 7.4 is 405.244. Okay, times pi times 4/3. So I'm not going to do the timesing by pi. I'm just going to do 4/3 times 405.244. So times 4/3. And I get 540.2986. And remember, this number has a pi on it. So my answer here, if we round it to 2 decimal places, so 29, you look to the right, that's 5 or more, so we're going to bump it. But 9 rolls over, and we'll call it 0.3. So we'll have 540.3 times pi. And that was a volume, so it's a cubic number, centimeters cubed. Now for surface area, we're going to do the same type of thing. We're going to find our formula for surface area, which is back at the beginning here. 4 pi r squared let me get a different color. Okay, so the surface area is 4 pi r squared. So again, r is 7.4. We'll keep pi looking like pi, and we'll multiply by 4. So first let's do 7.4 squared. That's 54.76. And then I'll multiply the 54.76 times 4. And that gives me 219.04 pi. And since that's an area, the units are square. Okay, let's try this one. This one is a right circular cone. So it's flipped over, but the shape is still there. So this shape is a circle. That's the base. And then the height is 7 meters. So let's think about, for volume, area of the base times the height. And then since it starts at a circle and ends at a point, we'll divide by 3 at the end. So let's do area of the circle first. The circle is pi r squared. So we'll do pi times 3 squared. That makes 9 pi. And now the height is 7. And then we'll divide by 3. So that makes 63 pi over 3, which makes 21 pi. And the unit on that, it's volume, so it's a cubic unit, meters cubed. Volume, I think, is kind of hard to picture what a cubic meter is, because, like, it's 1 meter by 1 meter by 1 meter, right? Which you can kind of picture. But then if they represent that 1 meter in a different way, like when you hear a car commercial and they're like, oh, this car has, 200 square or cubic inches more of space in the interior. Like, it's kind of hard to picture what that looks like to me. Anyway, okay, let's try surface area. So surface area for a cone, I don't know, I'm going to go back. Oh, surface area for a cone is kind of ugly here. Pi r square root r squared plus h squared plus pi r squared. Pi r squared plus h squared plus pi r squared. I think that's what it was. Let me just look one more time, just to make sure. Okay, I got it. All right, let's do this. So here, my r is 3 meters. H is 7 meters. Oops, I wrote H instead of 7. Okay. And then r squared. Okay, let's get this party started. So I've got 3 pi times the square root of 9 plus 49. So that's 3 pi times the square root of 58 plus 9 pi. So 3 squared is 9. So 9 pi. And now this is a pretty ugly number. Let's put it in the calculator just to practice rounding. So I'm going to add the directions. Round to the nearest thousandth. All right, so how do you put this into your calculator? Remember, your calculator has a pi button. So if it doesn't specifically say use 3.14, then you should use your pi button in your calculator. So what I'm going to do is first I'm going to do the square root of 58, which gives me a long decimal. I'm going to times it by 3, and then I'm going to times it by pi. And that gives me a very long decimal, 71.7769705.2. And I still have to add this 9 pi. So in order to keep that decimal in my calculator, I'm just going to hit plus, and then I'll put in parentheses 9 times pi, which was 28 something, equals. And I get 100.051304 ... And when you're rounding, whoa, sorry about that. we are rounding to the nearest thousandth. So that's 3 digits, 1, 2, 3. Now you don't just keep what you've got, you have to look to the right. So when I look to the right, I see a 3. And so that means 4 or less means keep what you started with. So I'll keep 0.051. So my surface area would be 100.051. And now let's see, what were the units on that? Meters. So this would be square meters because it's an area. Okay, let's try another one. If a spherical tank 4 meters in diameter can be filled with liquid for $850, find the cost to fill a tank that's 15 meters in diameter. All right, so let's look at the small tank first. Four meters in diameter. So the volume of this tank is 4/3 pi r cubed, right? That was the volume of a sphere. And we know r is 2. How come it's 2? Because it's half the diameter. So for volume, we'll do 4/3 times pi times 2 cubed. So that makes 32 pi over 3. So that's the volume of the first tank. Now let's look at the cost of the first tank. So it cost, what was it, $850. For 32 pi over 3 cubic meters. Now, I'm not actually going to do anything with that yet, but I'm going to need this orange step here. So let's move on to the big tank. So our big tank has a diameter of 15 meters. So what we know about the big tank is that volume equals 4/3 pi r cubed. And here r is going to be 7.5. How did I get 7.5? Half the diameter. So we'll do 4/3 times pi times 7.5 squared. And again, I'm going to keep it in terms of pi. Just stick with me here. So 7.5 cubed times 4 divided by 3 equals, so 562.5 still times pi. This is the volume of the big tank. Okay, so how in the world do we figure out how much it costs to fill the big tank? Well, we're going to use this orange conversion factor. So to find the cost of the big tank here, well, we know it's 562.5 pi meters cubed. And I know that for 32 pi over 3 meters cubed, it was $850. And now check this out. Meters cubed, those cancel. And so I'm going to end up having to do 562.5 pi divided by 32 pi over 3. So now you have to remember that for fractions on the bottom, you're going to flip them into timesing. So I have 562.5 pi. And now instead of dividing by 32 pi over 3, I'm going to times by 3 over 32 pi. And then still times 850. And now the reason we do this is because of keep, change, flip. But now mathematically, the pi's cancel. So the math that I'm doing is 562.5 times 3 times 850 divided by 32. Let's get that math. So 562.5 times 3 times 850 makes like 1,434,375. And I have to divide that by 32. So I get $44,824.22. Okay, let's try another one. Find the value of x. Find the value of x. So I'm told that the volume equals 60 and that the shape is a box. So let's find the volume of the box. So we know that volume is equal to the area of the base times the height. So here my base is a rectangle, a 6x4 rectangle. So the area of that base is 6 times 4, which is 24. And then the height is x. So the equation that I get here is 60 equals 24x. Because volume was 60 and volume was 24x. So since those are both volume, we'll set them equal to each other. Now to get x alone, we have to divide by 24. So we get x equals, we'll do 60 divided by 24. If it comes out to an ugly number, then we'll keep it as a fraction. But it came out to a beautiful number, 2.5. So the value of x is 2.5. So now just on this last page, when you're doing surface area, most of the formulas are not really that intuitive, but the box or cube, that's kind of intuitive, and the cylinder is kind of intuitive. So here you've got this base, which is a rectangle, right? Or it could be a square, but we call that length times width. So on here, I'm going to label this one length and this one width. But that's also here. And then this is length, and this is length, and this is still width. Now you notice I didn't mark these other two with lengths because these come from the height, right? If you're unfolding your box, these are the height of the box. Right? All of these come from the height of the box. So if you look, we've got a length width, we've got a width height, we've got a length width, we've got a width height, we've got a length height, and a length height. And so there's two length heights, there's two width heights, and there's two length widths. And that's where that formula comes from. For cylinder, I wish they had shown the cylinder standing up first. So here's the cylinder. Sorry, my drawing is so bad. Here's the height. Here's the radius. So this is the top of the can, and this is the bottom of the can. And you can think of this like the label of the can. So the area of the top and bottom are pretty straightforward, right? They're just pi r squared because they're circles. And now for the label, we know how high it is. It's height. But how long is it? Oops, sorry, that gotta be a little thicker there. How long is it? Well, it had to go around the whole can, so its actual length is the circumference of the circle. So 2 pi r. So if you want to find the area of the part which is like the label, it would be 2 pi r h. So put these three things together to get the total surface area. You'd have 2 pi r h plus pi r squared plus pi r squared, so 2 pi r squared. And if you look back in the notes, that's the area for the that's the formula for the surface area of a cylinder. Those are the only two that I feel like are pretty intuitive. The rest are a little they're a little iffy on intuitiveness. And this is the end of the geometry chapter.